Good afternoon. Apologies for being a half a minute late. Technical issues on the backside as usual. My name is Stefan Freeland. I am the coordinator of the Huxley Speaker Series. Welcome to our 10th and final series talk for winter quarter 2021. I want to again express my appreciation to the Salish Sea Institute and the Western Alumni Office who have co-sponsored this series. And remind you all that if you have missed any of them, we post all of the videos for the archival talks after they've been edited and captioned to our website, so you can find them there. And we'll be back next quarter with another series of talks. Today, I would like to welcome once again Laurel Ballou, who will do our introduction today of our speaker. Laurel is the Executive Director of American Indian, Alaska Native, and First Nations Relations, the Tribal Liaison for the University. And so it's our pleasure to have Laurel with us today. Laurel, thank you.
Thank you for having me. Okay. Yes, good evening. My name is Laurel Ballou. My traditional name is Sasyahamia Nancy Kutzbuksut, and I am the tribal liaison. It is my pleasure to introduce to you all this evening Dr. Marco Hatch, who is an associate professor of environmental science at Western and is a member of the Salish Indian Nation. And it's really an honor. It's actually kind of weird. I consider Marco a very good friend, and so I'm honored to be able to introduce him to you all. He is a marine ecologist who helps Native American students gain greater access to STEM opportunities while respecting the Coast Salish people, their landscapes and seascapes. Dr. Hatch has several publications. I was really impressed. I guess when he's not busy teaching, he's busy writing. So very impressive publication record. His work includes helping Native American students transition to graduate school in the geosciences, specifically connecting Northwest Indian College students to Western Huxley College of the Environment. And that's where I first met Marco, was at Northwest Indian College. His work focuses on the partnership between NWEC and Western called Partnerships in Geoscience Education. So I'm very excited to present to you Dr. Marco Hatch.
Thank you for the kind words, Laurel. Osin Chalchisiam, Sinasnat Marco Hatch. Hello, friends and relatives on this sunny afternoon near the end of the quarter. I just want to begin by acknowledging Lummi for allowing me to live and work on their lands for the past going on a decade now. And I think we often do land acknowledgements, and we often think of it in, of things people have done in the past. And our conversation before this started and was really around how Lummi is helping protect the community today, particularly in reference to being really on the forefront of distributing COVID vaccines, and both myself and wife are recipients of that generosity. So they've continued to protect both their memberships and the broader community, and both from health, and there's a number of environmental things we can talk about as well. So I was really thankful to have to be able to work in partnership with them. I'm going to give a talk, turns out. And hello to all my friends in attendance. It's sad to not be able to see you, but I'm happy to see your names in the participant list. Today I'm going to talk about clam gardens and how we can work within this ecological systems and think about both, the interesting ecological questions associated with this, but how can we also use this line of inquiry to increase involvement in science, both for Native Americans and also other populations. And so I'm going to walk through kind of a meandering little journey here and I am glad that you're all going to come along with me here. And of course, the professor does not know how to do a presentation. This is an image I often start my talks with because in the words of Thomas King, all we are is stories. And this picture means a lot to me. This is a number of my, some of my current students and former students and a whole bunch of folks coming together to help the Lummi youth canoe family move this canoe into the water. And I think there's some interesting symbolism here of a broad coalition of individuals helping these young people on their journey. I think talking about the canoe is also interesting. And I want to start by telling a story that originally comes from Chief Dan George. And it's often referenced as two trees, one canoe. Long ago, when a family needed a new canoe, they would meet with the community carver, and he would ask the family, what would the canoe be used for? Would it be used for short trips or long trips? Would it be used to visit family, to move through the islands or up a river? And in conversation, the carver would get a better understanding of why the family needed this canoe, what they'd be using it for, what was their intention and purpose. And then the carver then would go into the forest and select the perfect tree, perfect cedar tree. And he wouldn't simply cut it down. He would have a conversation with that tree and tell the tree about the family it would serve, what they would do with it, how it would help them connect with family and move through the islands during the seasons and harvest. And if the tree agreed, it would be felled, be cut down, and then carved into a canoe. However, today we no longer have those big cedar trees that we can make a canoe out of a single tree. Now we've the process is still the same with conversation and respect for the tree, but now we can no longer make a canoe from a single tree. Our trees are much smaller now, and because of that, we now need to make a single canoe out of two trees. And as those two trees come together to form a canoe, it's important that they meld well together. It's important that one tree doesn't think that they're better than the other tree, that they may have differences, but they need to come together around a mutual understanding and to come together to fit together well, to seal, to keep the water out, to keep the people inside the canoe safe, to move forward. And I often think of those two trees as traditional ecological knowledge and what we often refer to as Western science. That both of these knowledge systems are robust and important, and we need them both to go forward. And it's that connection that's going to help us move forward. And we can think of the canoe as the Salish Sea and us as the inhabitants of that canoe. And so it's important that we use all available information in a respectful manner to think about what does our future look like here, and how are we going to maintain our canoe, and how are we going to stay afloat in changing waters. And this brings up the question then, if that's our goal, who can do that? What sort of, this is a tough question. It's a sticky wicket, if you will. It's a hard thing to do. There's a large divide. There's a lot of history. There's a lot of tension between these two knowledge systems. And so if we agree that that's something we need to do to move forward to be able to have the best environment possible and the best chance of a healthy future, we need to think about how to respectfully engage in both of these knowledge systems. And the words like bridges have been used a number of times, but really this is a difficult process. And in our academic research, we've, of course, because we're scientists, have thought about this in relationship to a graph. Leave it to me to graph something like this. And so on our x-axis, we have the axis of science, which spans from discovery to solutions, discovery of wonder, curious questions that might not have a direct application into our sustainability or resilience here in the Salish Sea, moving to the other end of the spectrum around solutions, specific solutions to declining populations of important species or toxins. Then we have the axis of the individual along the Y, which goes from curiosity or wonder to worry or concern. I'm curious about if this intertidal ecosystem is top down or bottom up. I'm worried or concerned that the intertidal foods that I rely on are toxic for me. And established geoscience tends to hang out in the upper left here in the discovery and curiosity and wonder space. And communities that are underserved, disenfranchised, or frequently underrepresented tend to be in the lower right. And so if we think of this in the two-tree analogy, we need an individual that can span that boundary, that can bring tools and technologies from established geoscience to concerns, worries, moving towards solutions in many communities that have traditionally been disenfranchised, disengaged, or underrepresented in what we do in science. And so we focus on these individuals called boundary spanners, individuals that can, in this case, span that boundary between established geoscience and communities that both need that information and tend to be underrepresented in science. And the idea of a boundary spanner has been applied at the organizational level. Safford et al. Have a good paper looking at organizations that span those boundaries. And particularly these are things like land grant extension offices that can help individuals and agriculture with solutions around growing of plants and animals. And Sea Grant, which is actually part of their vision, where they envision a thriving coastal ecosystems and communities that are supported by an engaged public and informed decision makers. So there's organizations that this is part of their mandate. But one thing I learned from Dr. Guillory, the president of Northwest Indian College, is that this is in reference to my old position, that nice new buildings are nice, but it's the people within them that matter. And so when we look at organizations, who are the actual people that are functioning as the boundary spanner? It comes down to personal relationships, and it comes down to individuals. And so we are working on a project to analyze boundary spanners at the individual level. You'll recognize the handsome fellow there in the red life jacket from last week, Darcy Matthews, and then Sky Augustine sitting on the back here, two of my favorite people who are wonderful boundary spanners. So what does a boundary spanner look like at the individual level? It's typically a trusted individual or small team. There's a number of boundary spanners that are sort of like there are two individuals, maybe one person from the community and an outsider that they've been working with for a long time. The idealized boundary spanner tends to be a member of that community that also has credibility in their field. So having cred both within community and within their field, where they can frequently, figuratively or literally speak multiple languages, understand how to operate within community, but also how to operate within their chosen discipline. And these individuals are typically the fulcrum of partnership. And this really came about by looking at a bunch of projects that when we all look at, we're like, wow, that's just amazing the way that they've been able to integrate and work seamlessly with community and also ask fundable and publishable questions as well. And when you look at these large teams and these large projects that can be on the order of $5 or $6 million, it's really one individual that's like holding up all of that. There's like one, I've been teaching ecology, so the word keystone comes out every other week, or every other word. And granted, I'm a grandchild of Keystone, but the Keystone individual, the real fulcrum of partnership. And so based on our conversation with 6 different boundary spanners, we found that they have a certain set of characteristics. They have the ability to listen, they're a reflector or a mirror. They hear information and then share it back. Frequently a reluctant gatekeeper. So these aren't individuals that feel like gatekeeping, that they have the final say in what happens in the community, but their allegiance lies with protection of the community. They understand community protocol, and they also have cred in both the community and their chosen discipline. They typically function as an educator, translator, facilitator. They're frequently, when partnering with outside organizations, they have to advocate strongly for direct funding, equitable funding, and they frequently have to reinforce and clarify rules around data sovereignty and data sharing, things like that, protection of the community. And from the boundary spanners, when individuals that really live at this interface between community-based questions and the outside academic world, we talked about their ideal vision for partnership, and the one thing that came up over and over again is really developing of relationships before what's called an RFP, a call for proposals, comes out, to develop long-term relationships, frequently a decade or more. And before, I'm gonna say pen hits the paper, but before fingers hit keystrokes about writing up a joint project, we really need to figure out what everybody in the project needs to feel valued and honored. What are they looking to get out of this project, and how do they want to be involved and engaged in a respectful manner? Which brings us to this idea of an equitable exchange. This is work that's currently impressed by Laura Harris, and I don't know, there's like 15 of us on it. It's a cool paper coming out. But it's this idea of currency, that what's currency here, I'm standing in my office at Western, what's currency in my system are things like grant money and papers. That's likely not currency within academic community, or I mean within communities, in this case, Indigenous communities. And so we need to think about what's important from both of our angles and have open and frank conversations about that, so we can ensure that we're all understanding those currencies and making sure that everybody's getting equity out of the project. And frequently what we see, and what both of these projects have revealed, is that the vast majority of time, an outsider, somebody from an academic or institution or agency comes to the community and says, hey, I want to do this project with you, and here's what I'm going to give you. And it will be something like less than 1% of the overall budget, and it's all in predefined spaces. And we'll come back to that pre-definition of what community partnership looks like. We're arguing for a model here where we discuss those desires well in advance of engaging in any formal partnership, and understand what those community currencies are. Are they things like K-12 involvement, funding undergrads from that community, like students from that community? We don't know. We can sit in our offices and presume, but unless we ask, we're not going to know. And the goal of this really is to change the, excuse me, the modest proposal of changing the face of geoscience. And so here, and yet another graph, we can look at the participants, students coming into geoscience programs, and then the career paths. And we can look through the ways that things have been done traditionally, where you have a certain type of participant, a certain type of student that's selected through your program, that goes through a set definition of what it means to be a geoscience, and they come out the other side wanting to be a baby professor. And then we can start to open that up and start to increase inclusion by including more individuals from diverse backgrounds. However, we want to make them like us. And so it's okay if you come from a different background, but you need to come out as one of us. As this progresses further, then we start to include things like alternative pathways, where you're still going through a geoscience career, but now we're including other pathways post-graduation as a definition of success. And then ideally, we can move down to perhaps a system like D, where instead of having to go through a defined set of what it means to be a geoscientist, we can start to respect other forms of knowledge, other educational pathways that are not formal education, and we can start to include those people in our conversations. And this is more so than a child's chair at the table, but a redefinition of what does it mean to be a geoscientist? What does it mean to have scientific knowledge and be able to contribute to the issues that we're all sharing. And ideally, this is changing a fundamental shift of what science is and what does it mean to be part of science. And that brings us to clam gardens. I'm going to use two different terms here, clam gardens and sea gardens. Sea gardens is the way that the wind is blowing, and we're sort of adopting that language. However, I think clam gardens still has some name recognition. So throughout the talk, we're going to go through the transition of going to clam gardens and sea gardens, and you'll see exactly why as we get there. But for those unfamiliar, a clam garden is this really cool intertidal technology that's it's been found from Washington through Southeast Alaska. It's really remarkable in how widespread this technology is. And effectively, it's a way of, you can think of it as terracing the intertidal, the same way you terrace a hill to grow more grapes or trees or what have you. I never go up there, I don't know what people grow, but nonetheless, you roll rocks to the low tide line and you flatten a beach out, which creates more habitat for clams. And this is done not haphazardly, but with a great deal of precision, that the type of clams you're trying to propagate and to increase the growth of live at very specific tidal heights. They live at very specific zones in the intertidal. I often refer to this as the Goldilocks zone, where if you build your clam garden too high, the clams will dry out and die. If you build it too low, the sea stars are going to eat them all. And so there's a very specific zone that these things are built to and really engineered on the centimeter scale. And we'll talk about some work from the Southern Gulf. This is an image of Jefferson M., a former Northwest Indian College student here. And Jefferson's a good grew up on a farm, so he knows his way around a pitchfork, and he's helping clear off the seaweed here. And we'll talk about some work actually on this wall and then some work further north. And I want to begin with this quote, which is one I bring up in a number of my courses. It's that the Kwakiutl society was so populous due to the abundance of natural resources, especially the annual salmon runs, when in essence the food came to them. And I want to challenge you to think about that quote for a minute. This is Introducing Anthropology 2008. I did look it up, and it was still in the book. I think it's 2014 was the last version of this book I could find, but this is the anthropology book that's used in many universities, like Anthro 101 kind of thing. And so thinking about this quote, the Kwakiutl people, kind of northern Vancouver, were so populous due to the abundance of natural resources when especially salmon, when in essence the food came to them. So what is that quote saying? What does that mean about the people this quote's referring to? One way to interpret this is that the Kwakiutl people didn't have to manage resources. They didn't have to engage in any sort of complex interaction with the environment, any sort of complex stewardship, any sort of complex caretaking or modification, because they could sit by passively and huge piles of salmon would come and land in their laps. And this is the framework that is being pushed by this book and goes back for quite a ways. And it's really doing a disservice to the complexity of interaction with the environment that's been happening in this area for thousands of years. And with this sort of lens and this sort of framework that's been being pushed by this book, if this is your training, it would be easy to assume, well, there's nothing that we can learn from Indigenous people, that their populations were so populous just due to happenstance. And so a lot of our work is really pushing against that and looking at how for thousands of years people have interacted with the environment on an extremely fine and nuanced scale. And in the case of clam gardens, creating a massive new habitat, untold thousands of these things up and down the coast, creating tens of thousands likely of acres of new habitat, fundamentally changing the intertidal. And if we fail to understand that, the ecosystems we're looking at are the faded footprints of indigenous management that have been happening for thousands of years, we are going to come to false conclusions about the way the environment works, right? We are operating without the entire suite of information. And as scientists, we should want to have all of the information. We should want to know how landscapes got to look the way that they do. And we should want to know the same thing with seascapes, how they were formed over thousands of years and how we are looking at the legacy of that in our modern ecosystems. And so the failure to do that would be a basic failure in my argument of science. So here's a cool clam garden. This is Nathan Cardinal from, he's on loan from Parks Canada to Canada Nature. It's not the Nature Conservancy, it's something like that. Massive feature. This feature is a kilometer long. It's just huge, huge monumental rock features, to steal a word from Darcy. A feature like this, like I mentioned, is a kilometer long. You can see how wide it is, 20 feet wide. And then just in front of Nathan here, this drops off to about 10 feet of water. So just a huge pile of rocks, a huge, I mean, this clam garden weighs more than Stonehenge, right? Massive amounts of effort coordinated to build and maintain these structures. And this happened up and down the coast. Here's a map of the languages from Washington up through Southeast. So it's pretty interesting, like particularly when we compare and contrast it to something like ReefNet technology that's hyper local. Here's something that was shared up and down the coast. Drastically different cultures with different languages, but all engaged in a really similar technology. And the other cool thing about clams is you can do lots of things with clams. You can think about them in lots of different ways. Our work tends to focus on the mechanisms of clam gardens, why clams are fatter and happier, but we can look at it through a lens of changing oceans, identity, land and sea management, knowledge sharing, leadership, etc. I'm gonna have to cruise through a couple of these. So my lab, the Coastal Communities Ecology Lab, we try to focus on student success, science that matters, and partnership and outreach. And so we really want broad projects that are doing good science and also engaging communities in a respectful way. Through our work, we've found that place-based research, particularly with communities respecting Indigenous ways of knowing, is been really powerful in recruiting and retaining a wide diversity of students from a wide variety of backgrounds. And I'm excited to talk about two of those projects. One is Amy Rose Klein's work. We've been working together for a really long time now. We worked together back at Northwest Indian College, and she's a year after I came over, she came in as a master's student and is currently wrapping up the data analysis for her project, looking at intertidal co-Salish foods on clam gardens and other areas. And so this is one of the strongest arguments to stop using the word I keep using of clam gardens and moving into sea gardens. And so what we propose to do is look through the Southern Gulf at 2 known clam gardens and a number of rocky intertidal sites and ask the question, if I'm looking for something to eat, if I'm looking for intertidal food that is not clams, how do clam gardens stack up against rocky intertidal areas? Because the observation and the lessons have been that clam gardens are much more than clams, and hence sea gardens, that yes, clams are there, but if you pull your head out of the sand, you'll see there's a whole bunch of other stuff growing on the rock wall, many of which are traditional foods. And so we set up about running around the Southern Gulf, where she led a heroic effort with Northwest Indian College students, a number of Western students, and some free labor as well, to survey 48 different transects, counting up all of the critters, weighing all of the critters, and trying to figure out what about these environments supported traditional foods. And so we had 14 different traditional food species, things like chitons, limpets, red sea cucumber, red rock crab, scallops, things that have been consumed for a long time that aren't clams. And so really expanding the research on Indigenous food systems and understanding where those things are found, and looking at how, in particular, complexity, I'm going to use the word rugosity. Rugosity is just a word for how bumpy a beach is. How rugosity, temperature, and flow and algal cover relate to the abundance, diversity, and biomass of those traditional food species on these clam garden rock walls and other natural rocky areas. So we can see the full-foot clam garden here, a nice long pile of rocks. Young Octavio looking at a quadrat, and then one of these are called clawed cards. It's basically like plaster of Paris, and you pour it in a muffin tin and then it dissolves in relationship to flow. And to do this, she wound up counting and measuring 601 different individuals during our field work. And when you're in the field on the intertidal and the tide waits for no one, we don't have time to pop off every critter and weigh it. So we take lengths and then come back and do a length weight regression. So she did that for all 14 of her species, got good results. And so from there, we can take the length of these individuals and move them into biomass space. And based on her generalized linear model, there are two factors that explained most of the variability between the amount of biomass that we found on individual beaches. And those two things are water flow and thin rugosity, which I'll talk about next. And so if we look at, this is the biomass, so just, we don't care what kind of food you are, just how much do you weigh. So the total biomass per transect of the 14 different traditional Coast Salish intertidally sourced seafoods, and then dissolution per hour. And so this is how much of that little plaster of Paris muffin eroded with time. And the assumption here is that dissolution and flow are related. If you put one of these in an aquarium with no water movement, they dissolve quite slowly. If you put one of them under a fire hose, they dissolve more quickly. And so here dissolution is a proxy for flow. And one thing we can notice right away is we kind of have this intermediate result where it within middle, kind of not too high, not too slow, not too fast, sort of mid-level dissolutions tended to have higher amounts of biomass. And also clam gardens existed in a much narrower niche compared to the non-clam garden beaches. And that in particular is not unexpected. So what clam gardens are, the rock walls are put in generally low energy beaches. And so if we normally, when you want to figure out how much energy is at a beach, what's the current, how big are the waves, et cetera, you just look at the beach and it tells you based on the size of sediment. Flat, muddy beaches have less energy than rocky or larger cobble beaches. And so what clam gardens are doing is they're moving large rocks to the low tide where they normally wouldn't be. So it's fundamentally changing the size distribution of substrate. It's adding a bunch of kind of basketballish size to smaller size rocks on a beach, creating this really complex three-dimensional habitat. And it's doing it in generally lower flow areas as compared to rocky intertidal areas that can tend to have a lot of flow. We also have this one beach that's a real head scratcher up here with 1,637 grams of food on it. And we'll come back to that one, the next one as well. So keep your eye on that one. I'm not ignoring the high beach. So here's rugosity, and she inverted this index. And so here is more rugosity on the X, and then closer to the Y-intercept is less rugosity. Effectively, what you do is you lay a chain out, and if you can imagine laying a chain, a thin chain across your kitchen floor, a 10-meter chain would go 10 meters. And then if you stretch that same chain out over a rocky area, or let it follow the contour, it would not go 10 meters. And so it's an idea of, it's a way of using surface area as a proxy for that. And then here we found clam gardens are sort of in the middle of the spread, and there's some support for increased rugosity resulting in increased biomass, which you'd expect that the more habitat you have, the more biomass you'd have, because here we're measuring effectively surface area, which things like limpets and chitons need to stick to the rock. And so having more of it available would ideally increase more biomass. And then here, we'll come back, we'll talk about this site now. So this site was pretty interesting. We want to follow up with some folks about it, but it is chock-a-block full of chitons. Like this seems to be like the chitin spot. we had tons of mossy chitons, which is a good sized intertidal chitin, and a fair number of other chitons. You know, we would see like onesies, twosies on other sites, and then here we had 36, and they're quite large. And so that's really what's driving that distribution, is that we had relatively low diversity at that site, but just huge numbers of mossy chitons. So it'd be interesting to talk to folks to see if that's always been that way, if it's kind of known as like, if you want chitons, go to that spot. So there's probably something else in addition to flow and rugosity that could be driving that, why chitons love that spot so much. And we have a little bit of question around our flow. With high rugosity, it can get in the way of these clod cards because they can basically get protected in an eddy. They can be sort of shielded by a rock in front of them. So she's working through this and is finding some good ways of interpreting how and why we see different amounts of intertidally sourced seafoods, and also really showing how clam gardens are major contributors of that. They're different than natural rocky intertidal, but nonetheless, they are supporting a lot of really important traditional foods in addition to clams. And obviously the situation in the world has slowed down some of this, but she really has been working to get back and present back out to the partner First Nation communities on this and finish up that pesky thesis and get submitted. In the next few minutes here, I'm going to try to run through Octavio Cruz's work. Octavio finished up with me in the fall. And Sienna Reed, a undergrad here in environmental science, was really the savior of this project. It certainly wouldn't have happened to us without her help in the field. But we worked up on Quadra, which is the very northern end of the Salish Sea in between Vancouver Island and BC mainland. And Kanish Bay, which has been studied a number of times for clam gardens because there's so many of them. And so here we can try to look at the mechanisms of, it's been observed over and over again, including, I saw Amy Grossbeck in the attendance here, her pioneering work looking at how clams are, in common parlance, fatter and happier on clam gardens compared to non-walled areas. And so we were trying to figure out, what are some of the mechanisms of that? We have the observation, which is hugely informative, and now let's start to think about some mechanisms. And one thing is food. Generally, the more food you eat, the fatter and happier you are. And so his work was really to try to look at, can we use a diet-based approach and then look at a few other physical factors of explaining this difference in biomass and productivity of clams on sea gardens versus non-sea gardens. And so we went out in the field and measured lots of stuff, sediment grain size, some oceanographic factors, temperature and chlorophyll, and took samples for stable isotopes and fatty acids, two ways of trying to get at diet. And then I say Octavio, but really Sienna did most of this, of the shell weight index. And so one way to figure out how healthy a clam is to shuck it. You can see the snot looking parts of the inside of the clam that have been frozen for about a month. So you defrost a clam, take out the inside, and then dry it for like 2 days in an oven at 60 degrees, and then weigh the shell and your dried up clam goo. Thankfully, we did this at Northwest Indian College, not at my lab where I don't have any ventilation, but thankfully we were able to do it there. And so we have this shell index of like how happy is a clam, how healthy is a clam. And then we have these different diet profiles, and we can begin to look at that. And carbon and nitrogen space tells you a bit about the base of the food web, what type of phytoplankton are they eating, as well as how high are they on the trophic level. And the sea gardens tended to have a little bit wider of a spread in carbon space, indicating perhaps a more diverse diet, and a little bit higher in nitrogen, again, perhaps related to being slightly higher on the trophic on the trophic level. And then we can look at, and so perhaps, so this is showing some indication there's a differences in feeding between the two areas. And then we can look at some of the other mechanisms, including the type of fatty acids, which fatty acids are, if you've heard the thing, you are what you eat, that's basically fatty acids. We get our fatty acids from our diet. And so it's a way of getting a little bit more nuanced in what are the differences between diet. And we found that non-walled areas and sea gardens tended to group out differently in this RDA and kind of grouped a bit different. In general, what we were finding is the sea gardens, clams performed better there. They had a higher shell index that was roughly equal to the best performing clams in non-walled areas. And so what we were seeing is that sea garden clams weren't performing much better than non-walled clams, but the best, meaning the best non-walled clams could perform as well as a clam garden clam. But there's a much more variance in the non-walled clams. And so partially we think this is driven by temperature, dissolved oxygen and salinity, that we studied little necks and in their case, in higher salinity or even moderate salinity environments, moderate amounts of fresh water, moderately low salinities, they can alter their feeding behavior. And so it's looking like part of the story here is it's all about placement, is that these clam gardens, it's a massive amount of effort, and they were put in exactly the right spots based on the oceanographic conditions, based on if this entire area had never been modified and you said, okay, I'm going to invest lots of backbreaking hours of moving rocks, where should I do it? Based on everything we can measure, they're in all the right spots. And so it has a lot to do with, in this case, with salinity and dissolved oxygen as some of the primary drivers of the differences. So in conclusion, Octavio is he's graduated and is writing up his work. I have to end with the cookie story here. So I know everybody likes to get out of here at 5:20, but bear with me for just 1 second. So we've talked a lot about various projects going from, how do we think about moving forward together, and some more in-depth analysis that my grad students have been doing. And I want to take a minute to circle back to kind of where we started. And this is one of my favorite stories that I share quite frequently, with permission from Sky. And this is what she calls the cookie story. And the cookie story begins with two different groups of people that have traditionally had their differences. And they get together and they say, they get together in the kitchen, they say, we've had some differences. Let's think about a way that we can work together. Okay, sure. Let's make something. We're in the kitchen. Let's make something. Okay. Well, should we do something in the oven? Should we do something on the stove? Should we make a meat dish? What should we make? Let's bake something. Like, everybody likes baking. Let's bake something. Okay, sounds good. So and one group said, I have an idea. We'll go back to our home communities and we'll all get ingredients that are important to us, and we'll return tomorrow with all of these ingredients and then figure out what to make that's incorporating all of what we're bringing to the table. Everybody agrees and goes back to their home community. And the one group is very excited about this and talking about how this is going to be a different form of partnership, and hopefully this baking project will change the way that things have been. They return the next day, and the other group brings boxes and boxes of cookies, just beautiful cookies, all symmetrical and delicious looking. And they say, oh, we brought decorations. We want you can decorate these cookies we've made. And the other group says, well, we wanted to make bread. And in this analogy, it's a way we often think about how partnership is frequently done, meaning when we look at existing projects, proposed projects with Indigenous communities, it frequently is something like an outsider showing up saying, hey, I have a box of cookies, you're allowed to decorate them, which in our argument is not a good form of partnership, that we should start before the project has been baked, and the Indigenous people's involvement in the project should be more than that of mere decoration. So with that, I know I'm bumping up against the time. I'm happy to take any questions. Haishka, thank you.
Thank you, Marco. That's and I just want to say I love hearing about the sea gardens, that they're not just providing more habitat, a greater quantity of clams, but it's actually a qualitative change to the food source, the resource as well. That's great. There was one question going back to the slide on biomass and water flow, and the question was saying that the data looks fairly scattered, and wondering what the correlation coefficient value was. And I had sort of the same question: is that why such a wide range of biomass across the range of dissolution of water flow?
Yeah, I don't have the correlation numbers in front of me. They're in my email. But this was one of the two factors that wound up being significant in our GLM. Why was the biomass so different, or why was the dissolution so different? The low dissolution for the high site is cause for further inquiry, and Amy's working on that now. That one could have been caught behind a rock and not gotten exposed to good flow. For biomass, you know, I would expect a big spread. So one thing that's different between Indigenous people going out to harvest and scientists going out to count. And I've heard the story a million times with clam beavers I've worked with up and down the coast. You all are doing it in the wrong spot. So we've got randomized plots that we need to put out in certain areas, and sometimes those places suck for harvesting, right? So I'm not surprised that we found a lot of low spots, meaning if you have limited time and you wanted to maximize the amount of resources you go to, you probably wouldn't go to most of these beaches, but you would go to the upper end ones, right? If you want chitons, you would go there. You wouldn't go over here.
Sure, yeah. So then there was another question in terms of what are the limitations to the research? And are there technology, you know, if you had an infinite budget, what would you spend it on? And or is there a need or an opportunity for software, hardware, tools, tinkering to help the research as it moves forward?
Yeah, with my unlimited budget, I would hire Sky to run the program. We would think about, Hackai's done a lot of good work on the coast, thinking about a system that's maybe kind of building off or similar to what's been done with Coastal Guardians, but an Indigenous-led research institute on the coast would be great. And for software tools and technologies, I'm an intertidal ecologist, man. I'm rebar and PVC pipes, but you know, travel's been a big barrier for us. Octavio's work was much more analytical, looking at stable isotopes and fatty acids, and so to me, like thinking about really, you know, taking a lead from Darcy on like, you know, having a place and spending a lot of time in that place, I think would be one way to go instead of spreading resources out so thinly. The Nature Conservancy, I'm encouraged and trying to learn more about what they're doing on the Emerald Edge around engaging Indigenous groups. They just got a bit more funding. But I think it really needs to start at the top and then kind of be designed from the ground up.
Yeah. Question, are there sea gardens currently being managed in the Salish Sea or up and down the coast? Or most of those, we're talking about historic sites that we're looking at?
Well, as the Salish Sea map guy knows, yes, there are many in the Salish Sea. On the US side, if we want to be US centric, then not so much, but in the Salish Sea, for sure. The examples that Amy's working on, the Southern Gulf, so the best project around, an amazing project is the work done by the Southern Gulf Islands National Park. That's just entered their second project. So they've been doing restoration now for, I think, going on 6 or 7 years, which is engaging it's like 10 to 16 different communities around the restoration of these features. And it's just across the border. It's hard to get there, but if you could fly there, it's only about 35 miles away from here. So very, very close. There is a pesky international border in the way, though.
Yeah, I was wondering what that did to all the research, all your grad students.
Luckily, I didn't have a student last summer, but I got one day in the field with Swinomish. That was about it.
Yeah. Which leads to there was a question: are you accepting grad students on any of this work, and/or are there volunteer opportunities to support this research?
Yeah, we're slow right now. I have an incoming student to work on a really cool project on how people have dealt with biotoxins. And we have some samples we need to process, some leftover Octavio samples. And I just, with the current restrictions right now, I haven't been able to open my lab up. But in the fall, I do need people. I've basically, in this interim year, I'm going to have to start from scratch in the fall. I've got one student, if they'll still hang out with me. But other than that, between undergrads graduating and grad students graduating, we're going to have to come back and build a new team in the fall. So reach out then. I won't have anything this summer, but in the fall I will.
Yeah, and it has been a great demonstration of that undergrad and grad combination. So I'm sure you'll continue that. Well, that's great. I think we can wrap it there and let all of us return to our sunny afternoon. There's a number of comments that have been coming in of thank you and appreciation for the work. So I pass those along as well. As I said, this is our final talk of the series. We're going to take a couple weeks off, but we'll be back in the spring, Thursday, April 1st. No fooling. So watch for emails and announcements there. Marco, thank you so much for your work and your time today.
Yeah, thanks for organizing stuff. I know it's as somebody who never responded to your emails, I know it's quite difficult to get us all organized. So I appreciate your persistence.
Perseverance furthers. And Laurel, again, thank you for joining us today as well. So good. Thank you all. Enjoy the spring break.